Hi friends, very good morning. Welcome to Anu Academy. In today's class in our channel we are going to discuss BEE, Basic Electrical Engineering. Okay, so this Basic Electrical Engineering is for first year. It's a common subject for first year BTech students, and we'll start now. Okay, so here material is ready in front of us. We'll start discussing. If you are not subscribed to our channel, please subscribe our channel. Please like and share our channel. Okay, right. Now we'll start discussing. We'll start with magnetic circuit. Any part of the circuit associated with magnetic flux is said to be magnetic circuit. So you can see the diagram here. Okay, so this is the entire setup of this magnetic circuit. So this is the dotted line is the flux line. Okay, and this body, this is the circle shape is the iron ring, and here you can see coil of n turns. These are the coils of n turns, that is the part of this magnetic circuit, right? Magnetic circuits are closed. Next, permeability. This permeability is flux density by magnetic field intensity, that is equal to B by H. Okay, so you may get a question, explain these terms magnetic circuit and permeability. So these things you have to write. Okay, you have to draw this diagram for the magnetic circuit. Okay, next we will see reluctance. Okay, see here, next we are going to discuss this reluctance. Consider the relation shown below. In electric circuit, electromotive force by resistance is current. In magnetic circuit, flux is equal to mmf by reluctance. Okay, so in magnetic circuit, flux is equal to mmf by reluctance, right? So you can see here, for a given mmf, the flux in the magnetic circuit is reduced when reluctance is increased. Okay, so one can say reluctance is an impedance for the flow of flux in a magnetic circuit. The reluctance is given by L by A mu. Okay, so L is, where L is the length of the magnetic path and A is cross section area of the specimen through which flux is passing, and mu is permeability of the specimen, that is mu naught and mu r. Next, the magnetic field strength or magnetic field intensity. So magnetic field intensity H is the mmf drop per unit length and is expressed in AT by m. Okay, right. Next, we will see magnetic flux. Okay, in this magnetic flux, see, we'll discuss this magnetic flux. Any current carrying conductor is associated with the magnetic flux around it. Okay, so you can see this one, magnetic flux around it. They are imaginary lines. The unit of flux is Web. So flux is represented by phi. Okay, this is the phi symbol. Magnetic flux density, the unit of magnetic flux density is Web per meter square, or it is Tesla. If phi is the magnetic flux in the iron ring of cross section, a square meter, then magnetic flux density is equal to flux by cross sectional area. Next, magnetomotive force. Okay, this is magnetomotive force. A coil of n turns is wound on an iron ring and carrying a current of Ia. The mmf, so mmf is magnetomotive force of the coil is Ni. So the mmf is analogous to electromotive force in an electric circuit. So mmf is responsible for driving flux in a magnetic circuit, as electromotive force is responsible for driving current in electric circuit. Okay, so these are the subtitles, your subheadings you are getting in your examination. All these things you have to explain. Next, see here, magnetic field. Okay, a current carrying conductor pierced through a sheet of paper, as is shown in figure. So this is the magnetic field you can see in this diagram. Okay, so these dotted lines in a circle shape are magnetic flux lines. This is the current carrying conductor, and this is the paper. Okay, so magnetic field, you have to draw this diagram. If iron filings are sprinkled on paper, they arrange in the form of circles as shown in dotted lines. These represent magnetic flux lines. Any current carrying conductor is associated with magnetic flux lines and they are in circular shape. Okay, so that's all friends for today's class. I think you understood today's class. If you are having any doubts, please post in the comments box. I will give you a reply. Okay, so if you are not subscribed our channel, please subscribe our channel. Please like and share our channel. Okay, thank you very much. Thank you for watching.